Q series, priority marking. In the last issue, we introduced traffic classification, which classifies mixed inbound packets into different sets according to certain rules. Packets are classified into voice, video, and data services according to their service type. During non-peak hours, services can be transmitted at full speed without affecting each other. However, if data congestion occurs during peak hours, which service will be sent first? Priority marking is required to make this determination. What is priority marking? Priority marking is also called priority processing. Under priority marking, the network and device mark the priority of packets, and then they use this marking to process the packets. Why is priority marking needed? Assume that there are no priority markings. A network congestion occurs, and every service faces the same probability of packet loss or latency. The experience of users of voice services requires real-time transmission reduces dramatically. In this case, we need to adjust the priority of voice services to make them be preferentially transmitted even when there is network congestion. How can priority marking for packets be implemented? After traffic classification, priority marking is performed on the network ingress, and different applications are divided into 7 priorities according to the rules defined in the network. These priorities are also called classes of service. Class 7 represents the highest priority, and Class 0 represents the lowest. Most carriers agree that Class 6 and Class 7 are specified for key protocol packets and network control packets, which require low packet loss rate, low latency, and highest priority. The next highest prioritized services are voice, video, and other key data services. Non-key services and data services have the lowest priorities. Now that we understand planning priorities for different services, where in packets can we mark these cost values? In Layer 2 networks, the packet priority is marked in the PRI field of the Ethernet packet header, which is also called the A02.1P user priority. In Layer 3 networks, the priority is generally IP precedence or DSCP according to different standards. Because we have different bit quantities, these priorities can be used to achieve desired functions by mapping. We set priorities by determining and modifying values at these positions. In actual networking, the network planning can implement multiple priority processing policies for various networking applications. For example, in Layer 2 networks, priority processing can be performed based on external information about Ethernet service flows. The cost source of packets at the egress can be the outer cost, inner cost, IPTOS, or DSCP of the original packets. With proper network planning and processing, different types of services can be transmitted in an orderly manner, maximizing user experience. Let's learn about this in the next issue.